back when I first started teaching this. It's now chapter 3 because I used to do a preview chapter. All right, so we're going to go through each question kind of quickly. So pay attention, take some notes, make sure that you guys have the correct answers. All right, so the first one, it says that cosine squared of 3x, and it wants the derivative. So we're first going to rewrite so that we have cosine of 3x in parentheses, and it's all squared. So when we take the derivative, we're going to do the chain rule. Right now it's in the form u squared, so the derivative is 2u. So we keep our cosine of 3x the same. And then we do du. So we treat this like a new problem. We're like, well, what if y was equal to cosine of 3x? What's the derivative of cosine of 3x? It's negative sine of 3x times 3. So if you multiply that all out, you get negative 6 sine of 3x times cosine of 3x. First one down. All right, y equals natural log of x squared. You can take the derivative straight from there, or you can break it apart. Natural log of x squared is actually, you can pull the 2 to the front, so you get 2 natural log of x. So when you take the derivative, it's very quickly 2 times 1 over x. In other words, 2 over x. So if you plug in e squared, you get 2 over e squared, so b. So far, so good. All right, number 3. So we take the derivative, dy over dx, implicitly. So we're going to have 6x plus 2x times dy over dx plus 2 times y plus 2y dy over dx equals 0. And all of you probably did that correctly. But then the problem is you plug in x equals 1. So you get 6 plus 2 dy over dx plus, and then we're like, oh wait, but what's y? And we're stuck. So what do?
Plug that y into the original
Go back to the original equation. Exactly. So when we plug in y, we plug in 1, and we get 3 plus 2y plus y squared equals 2. This is what I was saying a lot of you guys on the test, like totally goofed on. And you're like, how do I solve an equation like this? And I was like smacking my head, like, please remember this. We've done this a long time, right? Algebra 2, you've done this. So subtract the 2, so you get y squared plus 2y plus 1 equals 0. Okay, so then when we factor, you get y plus 1 times y plus 1. So what is y? Negative 1. So plug in negative 1 to those spots. And a crazy thing happens. Do you guys see it? Yeah, the dy over dx's go away. So Grant, what was your answer?
Not defined.
It is, because you get 4 equals 0, which is not possible. So it is not defined. I know. Don't you hate when that's an answer choice too? You're like, surely it's not that, right?
The only reason why I put the problems that I get right in the extra credit section, and I put problems I get wrong in the regular section, so I'm wrong.
All right, so natural log of x to the 1/2 is how I'm going to rewrite this one first, right? So I pull the 1/2 to the front, so I get 1/2 natural log of x, and I take the derivative. So I get 1/2 times 1 over x, so I get 1 over 2x. Okay, so, oh, double prime, isn't it? Okay, so I was like, that's not an answer choice. I would have checked the wrong one. So this is 1/2 x to the negative 1, right? So if I take the second derivative, it's negative 1/2 x to the negative 2. In other words, it's negative 1/2 times 1 over x squared. So it's this one, b. Negative 1 over 2 x to the negative 2. All right. Still feeling pretty good about this? Number 5, just an algebra 2 question. I bet you could do this one, Olivia. All right, so look at it again. Oh, going back? I guess I can give you a blank one, Olivia. I kind of know what we're doing. All right. Yeah.
I'm good.
Just writing down everything. All right, so this one. So I have natural log of x minus natural log of 1/2. Okay, so if I'm combining these, right, I can't like do e raised to both sides yet because it's not like combined into one logarithm. So if I'm combining into one logarithm and I have subtraction between, I use division to combine them. So it's going to be x divided by 1 over x, which is natural log of x times x squared. All right, so we can bring the 2 to the front. We get 2 natural log of x equals 2. So natural log of x equals 1. Okay, this was a non-calculator test. Okay, so what is that? Natural log of what gives you 1? E. E is your answer. That's it. Next step. All right, arctangent. So arctangent is the old way of writing inverse tangent. So This is really saying y equals inverse tangent of cosine of x. So we know the derivative of inverse tangent of u, don't we? Yeah? Maybe? Totally.
One of
Right, that's one that's on your derivatives drill, so if you don't know it yet, you need to know it. All right, so we're doing the exact same thing. So when we take the derivative here, we're going to do 1 over 1 plus our u was cosine of x. So it's cosine of x squared times the derivative of u, which is negative sine of x. So our answer is going to be negative sine of x all over 1 plus cosine squared. All right, number 7. Number 7 is one of the hardest problems on the test. So what I did the year that I gave this test is I told you before that I gave them like a baseline score. So like the worst that anybody in the class could get is a 50% even if they got every single question wrong. These are actual AP questions. I made it challenging. I wanted to make sure that by the time they saw the AP test, they were prepared. They'd seen plenty of AP questions. But it caused a lot of anxiety in my students, and every single time they're like, oh, I'm going to fail, I'm going to get that 50%. Nobody got the 50%, but for the most part, people at least got 70%. So I stopped doing this. I made it more like Algebra 2, like where I give you a study guide, and then you guys have a test that's similar. But this is definitely a hard AP question. Okay, so we'll see if you guys got it. So it says, for what non-negative value of b is the line given by y equals negative 1/3 x plus b normal to the curve y equals x cubed? So if I have y equals x cubed, and I want to find its slope of its tangent line, I take the derivative. I get 3x squared. So this is the slope of the tangent. So what is the slope of the normal line? Yeah, it is negative 1/3. But what if I use this? It'd be 1 over 3x squared and then negative, right? Do you guys get that? It's the opposite reciprocal. So we want this to equal the slope that we talked about, the negative 1/3. So negative 1 over 3x squared has to equal negative 1/3. So what's x? 1 or negative 1. Okay. So this is where a lot of people were like, oh, the non-negative value. Oh, non-negative value is going to be 1. And then I circle b. So did you guys do that? B is not the right answer. What does it say? It says for what non-negative value of b, right? Not of x, of b. So we need to find the b value. So in order to find b, in the equation that has b, I have x and y. So in order to find b, I need to find y. Well, how can I find y? Plugging it back into the y equals x cubed, right? It's on the curve, right? So when I plug in 1, I get 1. So I have the point 1, comma 1. Or I have the point negative 1, comma negative 1, right? If I plug it in negative 1. So if I have the point 1, comma 1, when I plug that into the y equals negative 1/3 x plus b, I get negative 1/3. I add it over. I get 4/3 is equal to b, right? 1 plus 1/3. But if I plug this other one in, I get 1/3 there. I get negative 4/3. So that doesn't work. So it is 4/3 for b. So it's C. All right. That was a hard one. Did anybody get that? Ian, good job. Good. Syra? Yeah, no one else on the table? And, oh, I thought this table was going to be like the rock star table. That's right. I'm sure you got almost every other one right. All right, so this next one, the value of the derivative. Do you guys want to take the derivative with quotient rule, chain rule, chain rule? No. Don't. So what can we do instead? Natural log of both sides, logarithmic differentiation. So we're going to do natural log of y equals, and we break it apart. So we have natural log of x squared plus 8 under a cube root, so we're going to put a 1/3 power out front. Then we're going to have minus 1/4 natural log of 2x plus 1, like that. So we take the derivative. So we get 1 over y, dy over dx.
Carly Duncan, can you come down to the front desk? Thanks.
That never happens at our school. She has witnessed in my 8 years here. That's the first time that's ever happened. So for all of you guys, like, what's going on? All right, anyway, so we have 1/3 times 1 over x squared plus 8 minus 1/4 times 1 over, oh man, see, it's thrown me off. I can't handle the announcement. Yeah, it's Julie, I got it, times 2x minus 1/4 times 1 over 2x plus 1 times 2.
This is where my pride and joy stems from in my life.
She gets a bonus point. That's why I'm writing her name on the board. All right, so we get 1 over y, dy over dx, equals, I don't really need to clean it up, I guess. I can plug in 0, right? So what if I plug in 0? It's kind of messy. Can you guys see? Like the 2x makes all that go to 0. So that's gone. What about over here? I have negative 1/4 times 1 over 1 times 2. Yeah, so I get negative 1/2. So I had 0 and then minus 1/2. And a lot of people might be like, oh, it's b, but it's not. Why is it not b? Emerson's erasing. Right, we need to find y, right? So we go back to the original and we find y of 0. So the cube root of 8 all over the 4th root of 1 is going to be 2. So we have 1 over 2 dy over dx equals negative 1/2. So we multiply by 2 on both sides. And we get negative 1. That's the answer. All right, so if we have y equals the natural log of x squared plus y squared, when we take the derivative, we get 1 over x squared plus y squared times the derivative of x squared plus y squared. Yeah, so 2x plus what? Yep, exactly. And then luckily we were given a point. We were given 1 comma 0, so just plug in 1 comma 0. So when we do, we get 1 over 1 times 1 plus 0. So it's 1. Is that right? That's it.
Which was his number? Doesn't it become 0?
Yeah, because it became 0, right?
Yeah.
So this y prime over here is dy over dx, though, right? So maybe I should write dy over dx. 1 times 2, did I? Okay, I thought that answer wasn't the same as what I had earlier. Dang, Julia's going to get 2? Is she going to get 2? All right, 2. Kyle. Yeah. My wall of shame back here. All right.
So this way the answer is.
So it should be 2 times 1, which is 2.
Oh, I had that right.
Good.
Nice.
Good. Awesome. Good job, guys. All right. So the thing that most people had trouble with on this one is they didn't understand the notation. You guys know what the notation when it's a 2 means, right? d2y over dx squared. What's that?
The
Second derivative. So what's dny over dx to the n? The nth derivative. So there has to be some kind of pattern. So let's figure out what the pattern is. Okay, so if I have, let me write it down here. So if I have y equals e to the 7x, let's say. When I take its derivative, we should all know this, what do we get? E to the 7x times 7, right? So 7e to the 7x. All right, so if I take the derivative again, y double prime, I don't have to do the product rule because I have a 7, right? So the second part of the product rule would be 0 anyway. So I still have my 7 from before, and the derivative of e to the 7x is e to the 7x times 7. So I get 49 e to the 7x, right? So if I took the third derivative, I would get 49 e to the 7x times another 7, right? So there's a pattern. So if you have e to the nx for your original, the first one is going to be n e to the nx. The second one is going to be n squared e to the nx. The third one is going to be n cubed e to the nx. So what is the nth derivative? N to the n of e to the nx, because n is just a number, just like 7. All right, so it should be A. Okay, and then the next one, so I have f of x equals x squared plus 1 raised to the 2 minus 3x. Okay, this is in the form like something with x raised to something with x. Okay, so if we have something with x raised to something with x, what do I have to do? Natural log. There's no other like way to do that, right? So we take the natural log of both sides. So I replaced f of x with y. So I would have natural log of y equals 2 minus 3x can go to the front times the natural log of x squared plus 1. And then we take the derivative. So the derivative of natural log of y is going to be 1 over y term dy over dx equals, and I have to do the product rule. So here's my 2 pieces of my product. I circle them. So it gets a little messy. So I have 2 minus 3x times 1 over x squared plus 1 times 2x, right, the chain, plus derivative negative 3 times natural log of x squared plus 1, like that. Okay, and we plug in x equals 1, so we get negative 1 over 2 times 2 plus negative 3 times natural log of 2. Oh yeah, I remember this problem. This is like the worst AP question I've ever had. And I'll show you what I mean. Because I've told you before that the AP graders are awful. And they make things in the weirdest form ever. This is the weirdest form ever for the answer. All right, so anyway, so I get 1 over y. Go back to your original, find y of 1. If I plug in 1, I get 2 to the negative 1, which is 2 to the negative 1. Come on, guys. 1/2. So if I have 1 over 1/2 times dy over dx, what is 1 divided by 1/2? 2. So I get dy over dx equals, let's see, 1/2 times 2 is 1 times negative 1. So negative 1 minus 3 natural log of 2. And then I have 2 on the other side, so I'm going to divide it all by 2. All right, does that look anywhere close to any of these answers? No. And this was on the non-calculator portion of the AP test. Okay. So if it was on the calculator portion, you could always just like, oh, I got my answer. I'm just going to go ahead and plug in and get the decimal version and then check each of these ones to see which decimal is the same, right? So we know that it probably isn't 1/8 or negative 1/2. And looking at these, it's like, wait, how did I get this E in there? And it actually is one of the ones that has E. Notice how we have 2 separate terms on the top. Okay, they just have 1 term. It's like combined together. So think about the E. Can you see where the 8 comes from? Natural log of 8.
2 to the third.
Yeah, bring that 3 up as a power. So that's going to be 8. So we can at least see where the 8 comes from. So we're going to have negative 1 minus natural log of 2 cubed is 8, all over 2. What about 1? Natural log of what equals 1? E. So we're going to say negative natural log of E minus natural log of 8. That's what the trick is. It's not annoying.
That's pretty sneaky.
It is sneaky. And we still have to combine, so we pull a negative out. What is natural log of E plus natural log of 8? Natural log of 8e. So it's going to be negative natural log of 8e all over 2. Annoying, isn't it? That's like the worst one I've ever seen in this chapter, like with logarithms. They always do that. They always put them in weird terms.
Not getting less than 50%.
Yeah, so on this test, I let them choose 15 problems to do, so that's one that a lot of people skipped. Oh, whatever.
I'm at less than 50% right now.
Ah. All right, no, I'm saying like I would curve the grade so that if someone got 0 wrong, they would start out at 50%. That makes sense? Like I would never give them. All right, I had like a baseline score. This is the lowest that you can possibly get. All right, so this one, natural log of x, this one's an easy one. It's in the form natural log of u. The derivative of natural log of u is 1 over u du. So we're going to have 1 over natural log of x, and the derivative of natural log of x is 1 over x. So very quickly, it is just e, right? We like those ones. This one's not as bad as the one that had b before, but it's still kind of weird. So it says, if the line 3x minus 4y equals 0 is tangent in the first quadrant to this curve, then what is k? So if I have y equals x cubed plus k, and I take the derivative, I get y prime equals 3x squared. I want to find the tangent line slope. Okay, so I'm going to take this 3x minus 4y equals 0, and I'm going to add the 4y over, divide by 4, so I get 3/4 x equals y. So what do I do now?
3/4 equals 3x squared.
3/4 equals 3x squared. I was asking the other class if they could do this in their head, and they just like looked at me and were like, why would I be able to do that in my head? You guys can do this in your head. 3/4, right? 3 times 1/4 equals 3x squared. So x squared has to be 1/4. No, because 3/4 is the slope. Yeah, x equals plus or minus 1/2, right? So if we're in the first quadrant, x equals 1/2, right? All right, so we still need to find what k is. So what's the equation that has k in it? We have both x and we have y, right? We have y equals x cubed plus k. So I know what x is. X is 1/2 because that's the only one that's in the first quadrant. How do I find y? Into what? The original? The y equals x cubed plus k? No, because that's we don't know what k is. Plug it into the other one. So I get y equals 3/4 x. So 3/4 times 1/2, it's going to be 3/8. And then I plug it in. So I'm going to have 3/8 equals 1/2 cubed plus k. 1/2 cubed is 1/8. So what is k? 2/8, which is 1/4. It's B. So that one's a pretty tricky one too. All right. All right, so y equals sine of x. So it says y raised to the parenthesis n means the nth derivative with respect to x. So it says, what is the smallest positive integer n for which the nth derivative is equal to the original? That's what it's saying. Ah, close. 4, right? So the original was like, and then first derivative, second derivative. So it's the fourth derivative. That's the same. Yeah, so that one was just kind of hard to understand the notation. All right, this one, did you all get 15? Do you need me to do it? I think it is C, yeah. Yeah, it's C. Did you guys all get C for 15? Okay. All right. How about the next one? What did you guys get for the next one? No? It is close. It does have secant squared in there, but it's tricky. Okay, when we take the derivative of a tangent, I agree, is secant squared. So we're going to have secant squared of xy times the chain. So we need to do the derivative of x times y. So I have x times dy over dx plus the derivative of x is 1 times y, and then equals the derivative of x, which is 1. So I need to isolate this dy over dx. I need to get it by itself. So the first thing I'm going to do is I'm going to divide this over here. So I'm going to have x times dy over dx plus y equals 1 over secant squared of x times y. Do you think we left it as 1 over secant squared? No. How can I write that? Yeah, it's cosine squared, right? So I'm going to have cosine squared x times y. And then I'm going to subtract the y over. See where we're going with this? And divide by x. And that is my answer. So E. All right, number 17 was an Algebra 2 question. Not even an AP Calc question. It doesn't ask for the derivative of the inverse, it just asks for the inverse. So if I'm finding the inverse of a function, remember if I had y equals x over x plus 1, I switch my x and y values. So I get x equals y over y plus 1, and I solve for the new y. So when I multiply the y plus 1 over, I get x times y plus 1 equals y, so I get xy plus x equals y. I subtract my xy over, and then I pull out the y. So my answer is going to be x over 1 minus x. So C. All right, the next one has a trick. Okay, if I just had y, right? What can I do? Yeah?
Well, in that range, some of these trigonometric functions don't fit that range.
Oh, on the range here originally. Oh, I see what you're saying. So you got rid of them based on that? You could. You can eliminate choices. Like he's saying x is between 0 and pi, so he kind of eliminated some choices and said there's no way that I can use 0 to pi. All right, how can I solve for y before I begin? How do I get rid of the e? Natural log, right? So let's do that. So we're going to do natural log of the sine of x equals y. Now can you find the derivative of y? Yeah. 1 over sine of x, 1 over u. du is cosine of x, so it's cotangent of x. Easy, right? Do you guys like those tricks? So it's much easier than doing the implicit differentiation. All right, same idea on this one. Well, not same idea, but you would do the product rule for this. So you're going to have f prime equals first times derivative of the second, so 3, 1 minus 2x squared times negative 2, plus derivative of x is 1 times 1 minus 2x cubed, like that. And then you would plug in 1 for x. when you plug in 1 for x, you get -7. Done. You don't have to do anything else. You don't have to find the equation of the tangent line because this is the only one that has a slope of -7, so it's A. All right, number 20. So it says let f and g be functions that are differentiable everywhere if g is the inverse of f and g of -2 equals 5 and f prime of 5 is equal to -1/2, then what is g prime of -2? Okay, so that's a lot going on in that problem. It took me a couple reads to like figure out, like, what are they saying? What are all these values? And here's what works the best, I think. Replace your g with what it's equal to. We said g is the inverse function of f. So it's f inverse of -2 is equal to 5. And f inverse prime of -2 is what we're trying to find. So how do I find f inverse prime? Do you guys remember the formula?
1/f.
Prime of f inverse of -2, right? We flip them. So reciprocal, and then flip the prime and the inverse. So f inverse of -2, well, we were given that. F inverse of -2 is right here. It's 5. So I have 1 over f prime of 5. Well, what's f prime of 5? Right here, -1/2. So 1 over a -1/2 gives us -2. So -2 is the answer. I know, lots going on there, wasn't it? All right, and the very last one, can we make it easier on ourselves? What can we do to make this easier? Natural log of both sides, right? So when I do the natural log of both sides, I get f of x equals the natural log of 1 plus x squared. So when I take the derivative, I get 1 over 1 plus x squared times the derivative of 1 plus x squared is 2x. Okay? So our answer is 2x over 1 plus x squared.